Good morning students, myself Venkatesh, Department of CSE. Today we are going to talk about runtime environment. See, we can say runtime environment as runtime storage management. See, another name for runtime environment is runtime storage management. See, runtime environment, we can call it as a runtime storage management. See, in compiler design, the runtime environment will deals with various varieties of issues, like it will managing the process stack. It means the runtime environment will manage the process stack. At the same time, it will lay out and allocation of memory for various variables used in the source program. That means in a program we are going to use various variables. Definitely in the program we are writing the program by using the variables. For that variables, allocation of memory can be done with the help of the runtime management only. At the same time, next one is allocating and deallocating memory dynamically. See, what is meant by allocating? That means occupying the space, whereas deallocating means deleting the memory or free the space. This is allocation and deallocation of memory dynamically. That means while program executing. That means whenever program is executing, we can say it is dynamically. So allocation and deallocation of memory can be done by using the runtime environment. That means allocation and deallocation, we can say it is in the work of runtime environment. So next one is mechanism used by the target program to access variables. So this is also one of the issue. It deals with the runtime environment. At the same time, the mechanism to pass parameters. So this is also one of the issue it deals with the runtime environment. So all these are the various issues that deals with various varieties of issues of a runtime environment. See, whereas next coming to the storage organization. See, before going to see the storage organization, generally if we take any program, C or Java or C++, whenever we save the program, then the program will be stored in hard disk. So during compilation also, program resides in hard disk only. So but a CPU or processor can execute a program only when the program resides in main memory. See, so we can say that if the program resides in main memory, then only a CPU or processor can execute that program. So after compilation is over, the compiler demands a block of memory from the operating system in order to store that program in main memory. Why? Because it is the responsibility of the operating system to manage the resources such as memory, files, input and output, etc. Input and output operations, etc. At the same time, operating system allocates a free block of memory to the corresponding program. So at the same time, so the compiler use free block of memory in order to store that compiled program. This we can call it as a runtime storage management. So this is the definition of the runtime storage management. And next, coming to the storage organization structure, we have here one code area. This is the code area. Next one is stack data area. Next one is heap area. So next one is stack area. So this is stack data area. This is stack area. In between heap and memory, we have free memory. See, this is the low address space. So this is the high address space. See, first one we have code area, then stack data area. Next one is heap area. Next one is free memory. So this free memory can be utilized by both the heap and day stack. That means this free memory can be utilized by heap pod at the same time stack pod. So this is the storage organization structure. Next, coming to code area. So what is meant by code area? Generally during compilation only the size of the program will be decided. So before execution the size of the program will be decided. Whereas coming to code area mainly stores the executable code. Here after compilation linking will happen. At the same time we know that what is a linking. See, linking means link the object files of several library files into a single file. So linker produces a file called executable file. So the code area contain target executable file. That means this code area will contain the target executable file. Next, coming to stack data area. So what is meant by stack data area? So stack data area is mainly used in order to store the static variables as well as global variables. We know that what is a static variable, what is a global variable. See, what is meant by global variable? Global variable means it is useful throughout the program, whereas static variable means the value of the variable is persistent. That means it up to only one block. See, this is the regarding static data area. Next, coming to heap and stack. So here, in order to utilize this space in an efficient manner, we are going to use the areas called heap area and stack area. See, these two areas are mainly used for utilization of the space. Generally here, stack grows from high address space to low address space, grows from high address space to low address space, whereas heap grows from a low address space to high address space. These two growths are opposite to each other. See, what is a stack? See here, what is a stack? See, we know that stack works on the principle of last in, first out. Whenever a function or procedure is called, then an activation record get created in order to store activation information stack. In order to store activation record in a stack, we are going to use activation record. See, at the same time, what is meant by heap area? So here, what is the purpose of heap area? Heap area means heap is a dynamic data structure just like as a stack. So in order to allocate memory at runtime, we are using heap. See, for example, if you take C language, we have MLOp, CLOp functions or free functions. At the same time, by using these functions, we can allocate or reallocate the memory at runtime. See, if you take Java also we have new operator or delete operator. Why? Because new operator is for allocation of memory, whereas delete operation or delete operator are using deallocation of memory. These two data structures are used depending upon the situation. If there are too many functions or procedures, then stack is used more often. That is free memory occupied by the stack. So this is regarding heap and stack area. Next, we are going to talk about stack allocation space. Almost all compilers for languages that use procedures or functions or methods as a unit of user-defined actions manage at least part of their runtime memory as a stack. Each time a procedure is called, space for its local variables is pushed onto stack, and when the procedure terminates, that space is popped off the stack. That means the space will be freed. Next, whereas coming to activation record, see what is the activation record? See, what are the various fields comes under activation record? See, let us see what is the activation record. Whenever a function or procedure call occurs, then an activation records get created. An activation record information is pushed on the top of the stack. At the same time, see what are the various fields comes under activation record, or we can say it is a model of activation records. So these all are the fields of activation record. See here, first one is actual parameters, second one is return value, next one is control link, next one is access link, next one is saved machine status, next one is local variable, and finally temporary variable. So these are all the various activation record fields. So what is meant by actual parameters? We know that actual parameters are actual parameters is nothing but the parameters which are declared inside the calling function. What is meant by return value? What return value is nothing but if it is mainly useful in order to store the result of a function call, or whenever a function is called, then it goes to the function definition. Of course, definitely it has to be done. Once a function definition was successfully executed, it may return value to the calling function. In order to store that value, we use the return value. Next, what is meant by control link? See, control link is nothing but it points to a activation record of calling function. In order to store the address of a calling function, activation record uses the control link. Next one is access link. So what is the use of access link? So access link means it refers to the local data of called function, but function in another record, activation record. So next one is saved machine status. See, what is meant by saved machine status? See here, it stores the address of next instruction to be executed. See, next one is local variable. See, local variable, it is nothing but it is a variable up to a local. Next one is a temporary variable. So temporary variable means it needed during the expression evolution. So these are the various fields comes under. Next we are going to talk about heap management. See, what is a heap? What is a memory manager? See, what are the various properties of a memory manager? All those things we are going to discuss here. See, first of all, what is a heap? Heap is a portion of memory that holds data during the lifetime of the program. In the heap, generally the static memory requirements such as global variables will be allocated space. In addition, any memory that is supposed to be used throughout the program is also stored in heap. At the same time, hence we can say that heap is heap management is a important thing in the compiler design. Hence, managing the heap, we can say by using this one, managing the heap is very important. Next, what is a memory manager? What is a memory manager? What are the two main functions used by the memory manager? See, what is meant by memory manager? See here, memory manager is nothing but it is a software, special software called memory manager that manages allocation and deallocation of memory. It is a special type of software. What is the purpose of memory manager? See, allocation and deallocation of the memory can be done by using the memory manager. Whereas coming to what are the two major functionalities of memory manager? So first one is allocation, second one is deallocation. See, what is meant by allocation? When a program requests memory for a variable, then the memory manager produces a chunk of heap memory of required size. That means how much amount of size it requires. For that size only, it will give the allocation. At the same time, what is meant by deallocation? Deallocation is nothing but the memory manager deallocates the space and add it to the pool of free space so that it can be reused. That means that free space can be reused for any other storage purpose. Next one, coming to the what are the properties of a memory manager. See, whereas coming to properties, first one is space efficiency, program efficiency, second one is program efficiency, third one is low overhead. See, what is meant by space efficiency? See, space efficiency means it should minimum the total heap space required by a program. And the second one is program efficiency. What is meant by program efficiency? See, program efficiency is nothing but it should make better use of the space to run the program faster in order to increase the efficiency. Whereas next one is low overhead. See, what is meant by low overhead? Low overhead means allocation and deallocation should be efficient by using this low overhead. Next coming to memory hierarchy of a computer. So this is the memory hierarchy of computer. See, whereas if you take the memory hierarchy of a computer, first we have virtual memory, and the second one is physical space, and the next one is second level cache, and next one is first level cache, next one is register. That means here physical memory, cache, memory and register. See here register, cache memory, physical memory and virtual memory. See here these are the access times. So access time of virtual memory is 3 to 15 ms, whereas access time of physical memory is 100 to 150 nanoseconds, whereas register is 1 nanosecond. Here a storage space is virtual memory is greater than 2 GB, that means more than 2 GB, whereas a register is up to 32 words. So this memory hierarchy consists a series of storage elements with smaller, faster ones closer to the processor and the larger ones further away. Here a processor has a small number of registers whose contents are under software control. At the same time, next it has one or more level of cache, usually made out of static RAM that are in kilobytes to several megabytes. Next one is the next level of hierarchy is physical. That is, we can say this as a main memory made out of hundreds of megabytes or gigabytes of dynamic RAM. The physical memory is then backed up by virtual memory, which is implemented by gigabyte of disks. Data is transmitted as blocks of continuous storages. To amortize the cost of access, the larger blocks will be used with the slower level of hierarchy. Here between main memory and cache, if you see the main memory and cache, what will happen is data is transmitted in blocks known as cache lines, which are typically from 32 to 256 bytes long. Between virtual memory and main memory, data is transmitted in a block known as pages, typically between 4K to 64 bytes in size. This is the hierarchy of a memory, that is memory hierarchy structure. Next we are going to talk about locality in programs. This is one small topic, locality in programs. So what is meant by locality in programs? Here generally most programs exhibit a high degree of locality, that is they spend most of their time executing a relatively small fraction of code and touching only a small fraction of the data. We can say that a program has a temporal locality if the memory location it access are likely to be accessed again within a short period of time. We can say that a program has a spatial locality if memory location closest to the location accessed likely also be accessed within a short period of time. The conventional wisdom is that program spend almost 90% of their time executing 10% of the code. So that is why you can say program often contain memory instructions that are never executed. Programs built with components and libraries use only a small fraction of the provided functionality. Only a small fraction of the code that could be invoked is actually executed in a typical run of the program. At the same time, the typical program spend most of its time executing innermost loops and tight recursive cycle in a program. So this is the locality in program. Next we are going to talk about block structured language and non-block structured language. See what is the block structured language. See what is non-block structured language. See, what is meant by block structured language? Generally, this kind of language in which the selection of source code is a pair of brackets. It is a pair of in between brackets. The selection of the code. So this is the starting bracket and this is the ending bracket. Block structure language support a structured programming approaches. The basic operations of block structured language is set and reset. So set and reset. So these two are the basic operations of block structured language. First one is set and the second one is reset. See, what is meant by set? Set is invoked when a beginning of block is recognized during compilation. Whereas what is meant by reset? Reset is operation applied when end of a block is encountered. So these two are the basic operations of block structured language. Next, whereas coming to symbol table organization for non-block structured languages. See, whereas it is the, we can say, non-block structured language, it is a unit of code into a single module. At the same time, here complexity of the symbol table organization is determined by average length of searches. See, generally we are going to use 4 structures for organizing the non-block structured language. So those are, first one is unordered symbol table. So first one is unordered symbol table. See, and the same time the second one is ordered symbol table. Second one is ordered symbol table, and the third one is, see, tree structured symbol table. Tree structured symbol table. See, at the same time fourth one is hash symbol table. Hash symbol table. See, these 4 are the various structures of representing the non-block structured language. First one is unordered symbol table, ordered symbol table. Next one is tree structured symbol table. Next one is hash symbol table. See, unordered symbol table in the sense the order may be any way, whereas ordered means here we are not maintaining any order. Here ordered means the symbol table may be in order. That means whereas unordered symbol table means language with explicit declarations, language with implicit declarations. Whereas ordered means here what will happen is in order we are going to use variables or all are in alphabetical order only. Whereas in tree means we are going to form just like I said tree manner. Whereas in hash means we are going to use by using the hash table hash function we are going to implement these 4 structure for the non-block structured language. Okay, so this is regarding a runtime environment. See, what is a runtime environment? See, what are the various runtime environment structure, and at the same time next coming to the activation record. So what is the activation record? What are the various fields of activation record? Next one is a heap management. See, what is a heap management? What is a memory manager? So what are the various properties of a memory manager? And at the same time what is a block structured and a non-block structured language comes under symbol table organization. So please subscribe. This is regarding this topic. So please, thank you very much for watching these videos. Please subscribe DBS Talks.